Good morning, dear students. Today we are going to discuss about the leftover chemical properties of aldehydes and ketones. Few properties we have already discussed, so we will do the recap and then we will start the remaining properties. Let's see. As you know, aldehydes and ketones gives nucleophilic addition reaction followed by elimination reaction, reduction of aldehydes and ketones, oxidation of aldehydes and ketones, and few reaction which is based on the involvement of alpha hydrogen. So up till now we have finished nucleophilic addition followed by elimination reaction and reduction reaction. We have seen the nucleophilic addition reaction, how it takes place, and the formation of the addition product. In addition of water, you have seen that formation of 1,1-diol takes place, hydrate form which is unstable, so removal of water takes place which again give rise ketones. Addition of alcohol takes place in which formation of hemiacetal and acetal takes place, as well as formation of kettle also is possible. When you will add hydrogen cyanide, then it gives rise cyanohydrine. Cyanohydrine is obtained, and in the previous video I told you whatever the reactant is there, accordingly we will name the product. For example, if it is acetaldehyde, we call it acetaldehyde cyanohydrine. Next is the addition of Grignard reagent. In this, as the addition of Grignard reagent takes place, there is increase in number of carbon atom. So this is ascending of series. If we want to convert aldehyde and ketones into alcohol, either we can reduce it directly, but during reduction of 1 degree, if you will reduce, aldehyde give rise 1 degree alcohol and ketone reduce to 2 degree alcohol. But if you want the alcohol with increased number of carbon, then you must use the Grignard reagent. You will get the alcohol with a more number of carbon atom. Addition followed by elimination reaction. In this we have seen the reaction with the ammonia and ammonia derivatives. You will get different product. For example, when ammonia is added, there is formation of imines. Imine product is obtained with the ammonia. Next is the reaction with hydroxyamine. When hydroxyamine, that is NH2OH, is added, there is removal of H2O and formation of oxenes takes place. If the reactant is ethanol, then the formation of ethanol oxenes takes place. Reaction with hydrazine. Hydrazine is NH2 single bond NH2. Again there is removal of water molecule and the formation of hydrazone takes place. Hydrazine give rise hydrazone. So if this is the acetaldehyde, formation of acetaldehyde hydrazone takes place. Next is reaction with phenylhydrazine. The same way there is removal of H2O and formation of phenylhydrazone takes place. 2,4-dinitrophenylhydrazine. This is also known as 2,4-DNP. We call it as in short 2,4-DNP. So when aldehydes and ketones react with 2,4-DNP, then the formation of 2,4-diphenylhydrazone takes place. Hydrazine converts to hydrazone. So nothing here, also there is removal of H2O, and you will get the 2,4-dinitrophenylhydrazone. Here I have given you a flow chart. Please remember it so that you will come to know. Ammonia gives you imine, hydroxylamine gives you oxime, hydrazine gives you hydrazone, phenylhydrazine gives phenylhydrazone, then 2,4-dinitrophenylhydrazine gives 2,4-dinitrophenylhydrazone, and semicarbazide gives you semicarbazone. So please remember all this addition reaction followed by elimination reaction. Then we have discussed about the reduction of aldehydes and ketones. Reduction of aldehydes and ketones give rise alcohol and alkanes. Both the products are possible with a different reagent and the reaction. When we talk about the reduction, aldehyde reduces to form alcohol, which is 1 degree, and ketone reduces to form alcohol, which is 2 degree. Let's see. When we talk about the catalytic hydrogenation, then aldehyde, when react with catalyst like platinum, palladium, nickel, then it gives rise the alcohol, which is 1 degree. Few reactions are there which gives alkane, which already we have discussed. Here we have seen the flow chart that primary alcohol gave rise aldehyde on oxidation, and the reverse reaction, aldehyde reduces to form primary alcohol. Remember this concept. Secondary alcohol oxidizes to form ketones, and ketones reduces to form the secondary alcohol. Few reactions are there where you will see the conversion of aldehydes and ketones into alkanes. Clemenson reduction. In Clemenson reduction, ketone in presence of ZnHgHCl give rise alkane. Wolff-Kishner reduction, again it converts aldehyde ketones in presence of NH2NH2 hydrazine with the basic medium and give rise alkane. When you will do the comparison, you will find that reactant of both the reaction are same and product of both the reaction are same. Only the difference lies in its reagent. In case of Clemenson reduction, the reagent are zinc Hg in presence of HCl, and in case of Wolff-Kishner, the reagent is basic in nature. Next we have discussed about Mervin-Pondorf-Vulry reduction, MPVR reaction. MPVR reaction is also to convert ketones into alcohols, but here the presence of aluminium isopropoxide in isopropanol solution. The reagent is there, and that's why it is the MPVR. Now from today we will discuss about the oxidation reaction of aldehydes and ketones. Aldehydes are easily oxidized to carboxylic acid containing the same number of carbon atom, and the reason for this easy oxidation is due to the presence of a hydrogen atom on the carbonyl group, which can be converted into OH group without involving the cleavage of any other bond. So they are oxidized by strong oxidizing agent or by any other oxidizing agent like bromine water, copper ion, silver ion, etc. In short, aldehyde can be oxidized to carboxylic acid by mild or strong oxidizing agent. This shows that aldehydes itself gets reduced. So we can say that aldehydes are strong reducing agent. They reduces Tollens reagent to metallic silver. Fehling solution or Benedict solution to a red precipitate of cuprous oxide. These reactions you will see in the practical also. Let's see about the few reagents which will work for your practical, as well as here the aldehyde reduces these agents and gives a particular color to detect the presence of aldehydes. First is tolerance reagent. Tolerance reagent is an ammonical solution of silver nitrate and is prepared by adding NH4OH or NaOH solution to silver nitrate. Instead of NaOH, you can use ammonium hydroxide. Generally, we use this reagent in lab, ammonium hydroxide. So, it will give you brown precipitate of Ag2O, silver oxide, which just redissolve. When an aldehyde is heated with the tolerance reagent, then the silver oxide form get reduced to metallic silver. So here you can see first the formation of silver oxide takes place. This silver oxide in presence of ammonia water. This ammonia water is nothing but the ammonium hydroxide to give rise the tolerance reagent. In exam, the external for the practical can be asked for the formation of how to form the tolerance reagent. So this is the tolerance reagent formula and these are the reaction to prepare it. For the practical point of view, please do it sincerely so that during the Viva question you will be able to give the answer. Now when the tolerance reagent is ready with you, then how you will test? Aldehyde when react with tolerance reagent, it gives carboxylic acid. The product is carboxylic acid and the silver mirror is obtained. When you will perform in the test tube, then you will see in the test tube the walls of the test tube gets shiny precipitate. Silver thus deposited and shines like a mirror on this wall. So when you will see this wall during the practical, then you will see the silver mirror. That's why the test is known as silver mirror test. And this test is applicable for both aliphatic and aromatic aldehydes. That is, both aliphatic and aromatic aldehyde reduces tolerance reagent. Next is Fehling test. When we talk about Fehling solution is the alkaline solution of copper sulfate, CuSO4, copper sulfate containing Rochelle salt. Along with copper sulfate, there is addition of Rochelle salt. Rochelle salt is sodium potassium tartrate and is prepared by adding alkaline solution of Rochelle salt, that is called Fehling B, to Fehling A, copper sulfate. So you will get the Fehling solution which looks blue in color or deep blue in color after adding the Rochelle salt. When an aliphatic aldehyde is heated with Fehling solution, the Fehling solution get reduced to give the red PPT of cuprous oxide. So the reaction will be like this. When aldehyde is there, RCHO and copper ion because of Fehling solution. So copper ion and hydroxyl ion, when it is heated, then it gives rise carboxylic acid, Cu2O with the removal of water molecule. So here aldehyde react with Fehling solution where Rochelle salt is also there and you will see red precipitate. This red precipitate is due to Cu2O, which indicates the presence of aldehyde. In this Fehling test, aromatic aldehydes do not reduce as Fehling solution. Means only aliphatic aldehydes give this test. Benedict test is also same like the Fehling test. Benedict solution is the alkaline solution of copper ions complexed with citrate ion. It reacts in the same way as the Fehling solution. So when you will prepare the Benedict solution, then you will see there is addition of copper sulfate with the sodium carbonate and sodium citrate. So sodium citrate ion and copper sulfate solution together gives the Benedict reagent. Now Benedict reagent, this copper ion is coming from the Benedict reagent. When it reacts with aldehyde, the same way it gives carboxylic acid and red PPT of Cu2O in the test tube. Next is the reaction involving the alpha hydrogen. In this category, the most important reaction is aldol condensation. So, in aldol condensation, this condensation is between the two molecules of aldehydes or ketone to form beta hydroxyl aldehyde or beta hydroxy ketone. This is known as aldol. Al of aldol is for the aldehyde and DOL is for the ALD is for the aldehyde and OL is for the alcohol. So in this you will see aldehydic group as well as alcoholic group in the product. That's why it is known as the aldol condensation. In aldol condensation, the acidity of alpha hydrogen is partly due to the minus I effect of the carbonyl group, which weakens the carbon hydrogen bond, that is alpha carbon and hydrogen bond, and partly due to the resonance stabilization of the resulting enolate anion. Only alpha hydrogens are acidic. That's why this reaction is based on the acidity of alpha hydrogen of aldehydes or ketones. So the compounds, that is aldehydes and ketones having alpha hydrogen, can only give the aldol condensation. In aldol condensation, you can see this is the aldehyde, and when two molecules of aldehyde combine together, then there is a formation of the hydroxy compound in which OH group is there and aldehydic group is there. Due to the presence of aldehyde, it is ald, and due to the presence of OH, it is ol. So that's why this compound product is known as aldol. When you will see the mechanism in the first step, enolate ion is the anion formed when an alpha hydrogen in the molecule of an aldehyde or a ketone is removed as a hydrogen ion. So you can see here these two bonds, this will shift here and there is a removal of water molecule. So you will get the enolate ion. Now in second step you will see this bond get delocalized towards the oxygen and oxygen acquire negative charge, and this whole enolate ion moiety get attached with this carbon. So the alkoxide ion is the conjugate base of alcohol. In next step, alkoxide ion is protonated by water. So here you will see water is there. So what will happen? This will form the bond with H plus. This 2 electron, this bond will break and both the electron get shifted with the OH. So OH negative will be released and this hydrogen bonded and OH group will be there, which is known as the aldol product due to the presence of aldehydic and alcoholic group. So, in the presence of a strong base, two different molecules of aldehydes or ketones combines to form beta hydroxyaldehyde or beta hydroxyketone, means OH group will be at beta position. This reaction is known as aldol condensation. The enolate ion is the actual nucleophilic reagent. So this question can be asked in the reasoning. The reaction breaks down to the following. The alpha carbon of the donor attaches itself to the carbonyl carbon of the acceptor. When you talk about crossed aldol condensation, in case of crossed aldol condensation, two different type of aldehydes or ketone can combine to form the aldol product. If you react two aldehyde or ketone together in an aldol condensation, you will get four product. For example, if one of the reactant does not have any alpha hydrogen, it can be condensed with the another compound that does have alpha hydrogen to give only one organic product in a crossed aldol. So normal aldol condensation, if two different products are there, reactants are there, then there will be self aldol of the two and there will be two product by the cross aldol condensation. Here you can see propanol and methanol. Propanol and methanol. So it will give rise the product known as 1, 2 and it's 3-hydroxy-2-methyl propanol. Crossed aldol can also be done between an aldehyde and a ketone. One molecule aldehyde and one molecule ketone. The enolate carbanion from the ketone adds to the more reactive aldehyde. So what will happen? Here this will intact and OH will move from here to form the product. You can have the summary for the cross aldol and this question is there in NCERT also. When you will take ethanol and propanol, two different aldehyde. So out of this two product of the self aldol, when ethanol react with ethanol, second when propanol react with propanol. Now the remaining two are the crossed aldol condensation in which one time ethanol is the nucleophile and in the second one propanol is the nucleophile. So you will get the four different product in the aldol condensation. Two of the self aldol and two of the crossed aldol. Next reaction is the benzoin condensation. It is a coupling reaction between two aldehyde that allows the preparation of alpha hydroxyketone. Alpha hydroxyketone. So when two molecule of benzaldehyde combine together, then it will give rise the benzoin. This product is itself known as the benzoin. That's why the reaction is also called as benzoin condensation. So when benzoin condensation is there, then it is type of coupling reaction that you have seen in alcohols and phenols. Cannizzaro reaction is the very important reaction and it is just opposite to that of aldol condensation. In this, those aldehydes can give Cannizzaro reaction which do not contain an alpha hydrogen atom. When they treated with the concentrated alkali solution, then they undergo disproportion reaction, that is self-oxidation and reduction. So if two molecules are there, one molecule get reduced and other molecule gets oxidized. As you know very well, aldehyde on reduction gives alcohol and aldehyde on oxidation gives carboxylic acid. So you will not get the carboxylic acid exactly because NaOH is there. So acid react with NaOH and form sodium salt. So in all the reactions you will see the aldehydes which do not have alpha hydrogen atom get react with base alkali NaOH and one molecule get oxidized and other molecule get reduced. So you will get the mixture of sodium salt of acid and alcohol in Cannizzaro reaction. When we talk about crossed Cannizzaro reaction, when the mixture of formaldehyde which is not having alpha hydrogen and non-enolizable aldehyde are treated with NaOH to form alcohol and formic acid is converted into formaldehyde, this is not acid, formaldehyde converted to formic acid called crossed Cannizzaro reaction. You can see benzaldehyde and formaldehyde both in the presence of strong base. So as I told you, this is the reaction in which self oxidation and reduction takes place. So what will happen? This formaldehyde oxidized to formic acid and aldehyde reduced to alcohol. Iodoform reaction. When we talk about iodoform reaction is given by those compounds which are having CH3 CHOH group or the ketones which are having CH3CO group. When we talk about iodoform reaction, they are also called as haloform reaction. Why haloform reaction? Because iodine is the halogen. So instead of iodine, chlorine, bromine can also be there. So the reagent is sodium hypothalide, NaOX or X2 plus NaOH. In exam, if you will see these reagent, either this mixture or this alone, these are the reagent for the haloform reaction. So aldehydes and ketones containing CH3CO group, if this group is present, the other valency can be alkyl group, aryl group, 2 carbon, 3 carbon, benzene, doesn't matter. We are bothering about only the presence of CH3CO group. If this group is present, then on treatment with an excess of halogen in presence of alkali produces haloform. If chlorine, then chloroform, bromine, bromoform, and if iodine, then it is iodoform. In this, all the three hydrogen atom of the methyl group first replaced by halogen atom to form trihaloaldehydes or trihaloketone. You can see in the reaction the halogenating agent for the haloform reaction, halogen plus alkali. It form NaOX, which is the reagent. So either you can use directly NaOX or the mixture. So when it reacts with the aldehyde or ketone having this group should be present, right? So presence of CH3CO group is mandatory for giving the iodoform. So you can distinguish between the aldehyde and ketone or the alcohols. If the aldehydes or ketones having the CH3CO group, they will give iodoform reaction, otherwise not. For example, if CH3, CH2, CO, CH2, CH3. If this ketone is there, it will not give iodoform reaction. So you can distinguish the ketones with this. When it reacts with NaOH and I2, then please remember that this carbon hydrogen get replaced by the halogen and you will get the haloform. And the leftover carbon, this carbon forms the haloform. And the leftover carbon, whatever the number of carbon left here, they will give rise sodium salt of carboxylic acid. So this is the method to distinguish between the compounds having CH3CO group or not, because this haloform, if it is the iodine, if it is CHI3, then it will give the yellow PPT of iodoform. So in the practical also you will see this. Formaldehyde does not give this test. So formaldehyde is the exception for haloform reaction. Next is the Tishenko reaction. In this, ethyl acetate can also be prepared by this reaction, which is similar to the Cannizzaro. In Tishenko reaction, disproportion of aldehyde in presence of alkoxide happens to form ester product. We have seen in case of Cannizzaro, you are getting two products, one oxidized product and one is reduced product. Here you will see the formation of ester. Aluminium or sodium alkoxide is used as the catalyst. In the reaction you can see two carbonyl group are there. So what will happen? They get bonded. This bond will break and this get bonded and form the ester. Next is the Perkin reaction. Perkin reaction is first reported by the in 1868, and the synthesis of coumarin by the reaction of sodium salt. It is the anti-inflammatory, antioxidant, anti-allergic, antiviral, anti-carcinogenic activity. So here you will see, if we will see the Perkin reaction. In case of Perkin reaction, when salicylaldehyde react with orthohydroxycinnamic acid. These are the two reactants for the Perkin reaction, which will give rise this coumarin product. Here, this is the product obtained here. This is the intermediate and it get undergo cyclization and forms the product. Now, from this flowchart you will come to know that aldehyde or ketone gets converted to alcohol when you will reduce it, converted to carboxylic acid when you will oxidize it, and on reduction with the Clemmensen or Wolff-Kishner reduction you will get the alkane. In case of nucleophilic addition, addition reactions are also possible. Here this flowchart is there for your reference. If you will see the flowchart, then you will be able to do the conversion. How you can convert aldehyde and ketone to the corresponding alcohol and back to aldehyde ketone, carboxylic acid, back to carboxylic acid. So try to solve this flowchart by your own so that you will do the conversion easily. Some identification tests are there for the aldehydes and ketones. So go through this identification test. No need to remember all the tests. Few tests are there which you will do in the lab also, like tolerance, phalanx, DNP. You will not do, but DNP is important. Then in next you will see which reactions are given by formaldehyde, benzaldehyde, etc. So only go through these tests. So you will do the distinguish reaction. Thank you. God bless you. Have a nice day.